This project teaches you how to improve Docker image security in a practical way. You will learn how to scan an image for vulnerabilities, fix them by optimizing the Dockerfile, and compare the result before and after. Most security issues come from the base image, so choosing the right one makes the biggest differences. Flow description. This flow shows a complete setup process from an insecure image to a secure one. We start by building a vulnerable image and scanning it with Trivy to detect critical issues. Then, instead of fixing each vulnerability manually, we analyze the root cause, which is usually the base image. Next, we harden the Dockerfile by upgrading the base image, reducing dependencies, and minimizing the attack surface. After rebuilding and scanning again, we clearly see fewer vulnerabilities and a more secure image. Finally, the process is automated and ready to be integrated into a CI/CD pipeline, ensuring security is enforced continuously. Demo flow. The demo is designed to be simple and fast to run. First, install Trivy to enable vulnerability scanning. Then move to the project root folder and make the script executable. After that, run a single command to execute the full process: build, scan, fix, and rescan automatically. Finally, compare the generated report to clearly see the improvement in security. Now let's run the demo. We execute the script, which will first build a vulnerable image and scan it. As expected, we can see many critical and high vulnerabilities. Next, the script builds a secure version of the image using a better-based image and optimized configuration. It then scans the new image again. Finally, we compare the result in the report folder. You can clearly see that the number of vulnerabilities is reduced. The image is smaller and overall security is improved. This demonstrates an important lesson. We don't fix security by patching everything. We fix it by making better design decisions from the beginning. Before file, so many lines, and after file is shorter. One, 4, 3, 5. $46. $22. 2. Five, 6, 9. 50. What just happened? In the previous demo, we saw a simple but powerful workflow: build, then scan, then fix, then review, and scan. This is called the set of love. It means security is not something we do not at the end. Instead, we continuously improve security during development. First, we build a Docker image. Then we scan it using a tool like Trivy to detect vulnerability. After that, we fix the issues, review the image, and scan again. This loop continues until the image becomes more secure. Security is a continuous process, not a one-time task. Objects. In this project, we focus on 3 main goals. First, we learn how to detect vulnerabilities inside a Docker image. Second, we learn how to fix those vulnerabilities by improving the Dockerfile. Thus, we compare the image before and after optimization. The more important idea is that most vulnerabilities do not come from your application code. Instead, they come from the base image. That means even if your code is clean, your system can still be insecure. So choosing the right base image is extremely important. Project structure. Let's take a look at the project structure. We have a simple folder called Trivy secure image. Inside, we have a app folder contain the application code. Dockerfile view, insecure version, Dockerfile secure, improved version, scan, automation script, report folder, scan result. This structure is designed to clearly separate vulnerable setup, secure setup, and automation. This helps us easily compare and understand improvement. Simple app. This application is very simple. It is just a Node.js server that returns hello from vulnerable app. We are not focusing on application logic here. Instead, our focus is entirely on Dockerfile security. This is important because in real-world projects, security issues come from infrastructure, not business logic. Vulnerable image. Now let's look at the vulnerable Dockerfile. It uses Node 14 image. At first, this looks fine, but there are several problems. Node 14 is outdated. The image is late. It contains many known vulnerabilities. This is very common mistake in real projects. Developers often use old base images without checking security. Build and scan. Before, Next, we build and scan the image. We run Dockerfile and Trivy image command. After scanning, we see the result. Many critical vulnerabilities, many high vulnerabilities. This means the image is not safe for production. Even though the app is simple, the system is risky. Root cause. So what is the main cause? About 80% of the issues come from the base image. The Node 14 image includes outdated system practice, unnecessary components, later attack surface. The bigger the image, the more chance for vulnerability. This is why choosing the right base image is critical. Secure Dockerfile. Now we fix the problem. We update Dockerfile to Node 18 on Pi. This trend brings major improvement. Newer Node version on Pi Linux very lightweight. Fewer packages, fewer vulnerabilities. This is called image hardening. We reduce everything that is not needed. Build and scan after. Now we review and scan again. Run Dockerfile and try the image again. The result is much better. Fewer vulnerability, much fewer critical issues, smaller image size. This shows how effective a simple change can be. Compare before and after. Let's compare the result. Before, base image Node 14, size large, CVE very high, reach high. After, base image Node 18 on Pi, size much smaller, CVE reduced significantly, reach lower. One small change in the base image can drastically improve security. Automation. We also use a script called scan. This script automates the whole process. Build then scan, then fit then scan. Why is automation important? Save time, reduce human error, easy to integrate into CI/CD. In real projects, this runs automatically in pipeline. Workflow. Finally, let's summarize the workflow. 1. Build vulnerable image. 2. Scan with Trivy. 3. Identify vulnerabilities. 4. Fix Dockerfile. 5. Review image. 6. Scan again. This is a practical set of workflow you can apply immediately. Finally, security is not complicated, but it requires awareness, correction, and continuous improvement. Start with your base image. It makes the biggest impact. Thank you.